Hello everyone, I'm Said. In this video, we are going to talk about Entity Framework and how we can optimize our queries. I try to show you a real world scenario that you may face in your daily job, in the projects. So I try to consider all of the options that we need to check when we want to optimize a query or database side, application side, all you need for the optimization. Okay, let's see what we have here. I already created a project, sample project that we need to work on it to optimize the queries. I'm using the .NET 8, the latest one, the latest LTS one actually, and also the Entity Framework 8. Here is our entities. We are trying to simulate a kind of a company that handle the users and also the employees, the payrolls, everything. And in database, we have around 15,000 users, 7 departments, 25,000 employees, and also 30,000 payrolls. I try to simulate the real world projects because when your database is empty, every query is fast. So what's the point of optimizing? I just dump some data into this table so we can have better database to optimize the queries. Imagine that we have one API that your lead try to optimize it and tell you, okay, this is the time for optimizing this query. This is a legacy code. Imagine that this is a legacy code that developers that already developed these queries or API left the company and no one to blame actually. So if I run the project here, okay, our project is running and this is our API for employees. I already created another endpoint for our query optimization. We don't need it right now. So this is employees API. Let me call it by Postman so that we can see how long it takes to run. Okay, as you can see, it takes time. It means this API for sure needs to be optimized. It takes lots of time, still no response. Maybe this is the first time that we are running the project, takes time to warm up. Okay, 24 seconds, that for sure doesn't make sense. Let me run it again. Okay, 9 seconds, better. Because usually when you're running your project local and debug mode, the first time always takes more time. So imagine that this API is a bottleneck for your application, so you need to optimize it. Okay, first of all, you need to think. This is your first task in the project and you don't know much about the business logic, right? So first of all, you need to know what exactly this API return. Okay, so if I open this Swagger, here is a short description about this API. This API return 3 column: name, username, company name, and top 2 employees who belongs to backend or cloud department. Imagine that there is a lot of employees that belongs to different departments. And those employees at least have one bonus payroll and they are part of the company that founded in 2022. Okay, so this is all your information about this API. Okay, when you're trying to optimize a query, first of all, see Entity Framework queries. And what Entity Framework generate when you are calling the API, see the logs. Okay, here is our log in the console application. By default, I think Entity Framework 8 enabled the logs. Actually, you can see here in the app setting, the default one is information. So every logs in the different libraries that raising this log information, you can see in the console one. But in any case, if you want to enable the logs in application in the DB context, you can easily enable the logs using log2 and then passing, for example, you want to write those logs in console. Okay, and also you can even set log level for information. Okay, but we don't need it here. Actually, it's enabled by default. Here is our API. It's accepting employee repository and then just return get employees. Okay, so here the place we go. because we need to check what is inside this get employees, what they are doing that takes lots of time to respond. Okay, so let's go here. This is the query. You should think no need to start blaming the other developer. Okay, what kind of this code, why they didn't follow the best practices, everything that you are trying to say, it's already done. It's working for the company. It's your turn to optimize the query. So keep calm and then check this method step by step, line by line, and then try to optimize it. Okay. In this description, we need to take those employees who belongs to backend or cloud department. This is the first step for getting departments, that is backend or cloud, because we need those department IDs. And by context that employees, including this information, and return the DTO of employee, and then again filtering some data on it. Okay, as you can imagine, this is not a good code. The first thing that you need is what they want from your API. What data you need to fetch from your database. Here they say name, the employee name, username, their user that log into your system, and also the company name. These three properties they need only. No need to get extra data. This is very important option that you need to consider every time you need to optimize the query, right? Because first of all, it takes less bandwidth of your network when you have less data. And also you don't need to join many tables to just get unnecessary columns. So here, name, username, company name. We have this employee DTO. We have the name, username, and also company name. Maybe during the time they were developing extra features and forgot about removing these extra columns. But now this is our mission to remove everything we don't need. Okay, so we need to remove all of this unnecessary property. This is the main method. I need to put all of this code. I just want to keep those code untouched and start doing and tuning my code. This is a really good one. Not break current code that is already working for sure. This is a slow, but it's working at least. So I'm trying to put the code here in tuned code. I don't need asynchronous operation. I just want to keep everything simple here. So let's start with removing extra column here. Name I need. This column is just unnecessary data. Okay, company name, we need it. Okay, now we remove all of these unnecessary columns from the select, but we need to care what else in the rest of the code. Is there any columns that they are using or no? For example, they are ordered by the ID. I know this is not good practice, but we need to optimize the query to not breaking the main one. So because after select, they are ordering by the ID, we need to have ID here as well. And if you check this condition here, there are query on department ID and also the payrolls, right? Still, we need this department ID and payrolls. After we change the query, we can remove all of this unnecessary data. Now let's run the project again and run this tuned API and see what is the difference between the main one and what we did about the optimization. Let me run it again. 10 seconds. It's taking time. You can see all of these extra columns that we don't need is already null, but it's still working. So we did the first part of query optimization for removing all of unnecessary data, right? The next options that you always need to check is database round trips. You should always take all of the data that you need in one query, okay? So as you can see here, we have this query that taking the departments from database, which is independent query. It means you first getting the departments from database and then using this allowed department in the later on. What else we can do? We can just query these departments right here. For example, I can say employees where, or just copy these conditions here because this is part of the department. We can say employee.department.name and here as well department. With this simple trick, we just remove one unnecessary query from running on our database. So we can safely remove this one. Also, we can remove this condition as well. Okay, because we are getting and checking employees one by one and checking the department. But we already set this query when we are get all of those employees, right? And also this kind of extra includes, we don't need it. For example, when you are trying to get x.company.name, actually EntityFramework is smart enough to join the tables to get this company or maybe this users or payrolls, everything. So we don't need any of this kind of includes. You can remove all of them safely until maybe you have some mapping stuff that you need extra data from it. But here in our case, because we select what we need, we can remove all of those includes. What else? We already removed one extra query here, but one of the worst things that developer can do is putting this tool list here. Before building your query, you are to put this tool list, for example, here before even select or order by. What happens when you are to put this tool list? You are telling EF, run the query for me. It means until this point, what we have here, we are trying to say employees, where those employees is only belongs to the department for backend and cloud, and then tool list. It means we are getting all of the employees in database that only in the backend and cloud. But based on our requirements, we need extra conditions as well. Like the company should founded in 2022, for example, or even payrolls should have bonus. That employees should have a bonus payroll. What happens here, we are getting all of the employees from database and then we put those conditions on the application side, which is very bad. You can see that, for example, you are getting 1000 records from database and then filter those records on the application side and then only return, for example, 10 or 20 records. Why not just getting 10 records from database directly, right? Makes sense. Okay, so we can remove this tool list here as well and merge this where clause here. We can say company founded at toString contains, which is very weird code actually. Why? We need to check company should founded at 2022, which is the year of that date time. This founded is a date time. So why not just, I can say that year equal 2022. What we were doing before, we just make that date time to a string and then compare or seeking for 22 as a contains, right? Which is really bad because it doesn't make sense. We have a date time, then we can get the date part of year and then check the year only. This is very fast. When you are comparing the integers, is faster than comparing or checking the strings, the characters. So here also we did another condition. Another thing that bothering us is this payrolls. As this condition is saying top 2 employees that at least have one bonus payroll. And what we are doing here is still we are getting all of this result from database and then on client side we are check payrolls. So why not put this condition as well to the database? So we can put another condition here as well that we are saying payrolls dot any, just like that. It means we don't need this for each at all. And also this result is useless here. So let's just remove it. What we have currently, we are trying to get all of the employees and putting all of the conditions to preventing extra database round trip, right? So we put all of the conditions that we need, backend or cloud department, and also bonus payroll and company founded in 2022, right? So now we need to remove all of this extra stuff. I don't need the department ID and also the payrolls because already I put all of these conditions on database side. So we are sure that we are getting only those employees that is matches with our conditions. But they are saying that we need only top 2 employees. Here, this tool is, again, we'll get all of the employees that matches this condition here. So we can simply say, take 2, and then that's it. Here we can just say, return the employees. So from this long query, we are here. So far is good. At least in the case of the code lines, we did good, I think. Let's run the project again and check the responses. Because keep in mind, when you are optimize a query, it's easy to break the current API. Maybe you miss some properties or maybe you miss some the requirements. So always is better to check with the old API and new API that you are trying to optimize. Our API is running. Let me run this API, the first one, 26. Let me run it again. You can see that in the second run, it takes around 8 seconds. How about our, okay, it's taking around 1 second. Means by doing this stuff, not getting extra columns or putting all the conditions in the database side, we could reduce from 8 seconds to 1 second. Let me call it again, taking less time, that's fine. And now our API is a little makes sense. In a real world application, when you have this kind of API, and if this is a hot path, it should take less than 1 or 2 seconds. What else we can do to improve our query here? We already put lots of conditions on the database side, which is fine, totally fine. And also we just did 1 round trip against our database. But for example, here, if we check generated query, let me just copy this query that already executed. So this is the query that is generated by EntityFramework. If we run it here, we can see name, company name, and also the username. Also, you can have another DTO that only contains the data you need. We can do it. But I think for now, just for this video, let's reuse the same model. But be sure that if you want to change the API response, this is kind of breaking change for your clients. You need to always notify all of the clients. I'm going to remove these properties from the API. Maybe somewhere in the, I don't know, mobile application or your web, they are use those properties. They are unnecessary, but still they are using it and you need to tell them. Anyway, here we have these 2 records that is returning for this query. One of the trick that you need to always check, this kind of hard code or this strings in the query is not good because of execution plan. When you have this kind of hard coded one, they cannot cache, or SQL Server in my case cannot cache the execution plan. So maybe it's better to use another approach. What is better approach is you can have this one, the array of, for example, departments. You know that in C#12, I think, you can create or instantiate the array like this. So we have backend and also cloud. And we can use contains for department. We can say department.name. What we did just now, we created an array in client side and then send this array as a variable to our query so that we don't need to use this hard code string in our query. Let me run the query again and see the generated query for SQL Server. If I run the query and see the logs that EntityFramework generate for us, this sensitive data, I just enable it for seeing, for example, here the parameters, but you need to make sure that for the production, you are disabling this sensitive data logging, okay? This is a new query. You can see parameters here is department and is array of backend and cloud, right? The beauty of one of the features in EntityFramework 8 is use this OpenJSON for array. When you use the contains part, the contains method before .NET 8, it was translated to in query. For example, they say where department name in this values. But after .NET 8, they are trying to use this OpenJSON, which is much better in case of the readability and also performance. So here, just check the list of this string. Okay. You can see this query be better. It's about following the best practices. I mean, we are trying to use this list here and also the contains so that you can put lots of other conditions and it's more readable in the EntityFramework side. So we have the application side and your database side. Always in your database side, you can use indexes on your table. For example, here, you need to check all of these where clauses that you are using. For example, in employee name, you are using the employee name. You are filtering the year. Another one, the payroll type. But don't try to create the indexes on the table on the fly. Why? Because indexes are expensive for your queries, for your database. As much as you can tune your query on the EntityFramework side, that's fine because there is no cost for you. You just follow the best practices for the optimization, like the round trip, like the getting required columns, putting all of the conditions in database side, lots of things, right? That's fine because there is no cost for you. But once you are trying to create index on database side, there is something that you need to care. For example, when you create index, okay, that's fine, that's good. It will speed up your query, but use more storage of your server because of those storing indexes. And also, index is good for select, but is not good for write operation like the update, like delete, insert. You need to be careful about it. I don't want to create index right now, but always it is a good practice to check the execution plan of your queries. Okay, I cannot create it because there is one arrays that is passing by the EntityFramework, but you can see there is one execution plan, right? Here, SQL Server suggests that you can create this kind of non-cluster index on your table for the payrolls. But I think this is not good. It's just trying to create index for this specific query, and you should consider all of other queries as well. Okay, when you are creating index, you need to think what kind of queries I have, the tables, the database, everything, and then create the index for making your query faster. Just keep in mind, if you don't know about how to use this execution plan, please leave a comment for me. I can create another video about the execution plan, how you can create indexes, and also I have another video in the SQL Server about how SQL Server trying to use the indexes. So go and watch it. It's really helpful. So that's all we did for this EF tuning. So we have two APIs for the employees and also tuning, because this is the final query we did. I want to run the benchmark for comparing these two queries here, just for checking how it works and how long it takes in real time, because I'm using benchmark.net, so we can just run these queries and against the database, okay? already have another file for benchmark. This is the get employees and also the tuned one. So let's just copy this code and return employees. And also I need to create, I will put all of this code in the GitHub, so don't worry about the code. You can after run on your systems. So let's just run the project and after we can show the result for you. Okay, so this is the result from the benchmark. You can see that, okay, on debug mode, it maybe takes more time, but here on release, the query taking around 3 seconds, more than 3.5 seconds, but our tune query is taking around only 1.27 milliseconds, which means we are successfully tuned that query with 28 times faster. Right. And also you can see that even on the memory allocation, we did really great job because as you can see in the old query, we were getting all of those records from the database, putting in the application memory. So that's the really bad part of that code. But when we are trying to put all of the conditions on database side, we just get all the records that we need, nothing more. Right? So for this reason, even memory allocations reduced a lot. And also we optimized the query 28 times faster, which is a really good one. Please let me know if you know better approach for query optimization. Maybe I missed something to check. However, this queries is based on the project. I know, I agree that maybe this is a different part of project. Maybe you have different logic for getting data. So that depends always, I agree. But all I explained here, you can put all of this consideration for all of your queries. I'm sure that if you are, for example, putting the conditions on database side, getting only the data you need using the pagination, for sure you can optimize the query maybe at least 1 or 2 times faster, right? That's it for today. Thank you for your time for watching my video. Bye.